As we look to apply the ideas of the Pythagorean theorem, the distance formula is quickly our first and easiest way that we can use the Pythagorean theorem most effectively. The distance formula merely talks about the points with coordinates x and y for both 2 points. So, what I'm going to do is I'm going to call this one point 1 and this one point 2. So, as we look through it, this will be x1, that will be y1, this will be x2, and the second value will be y2. So as we put it into our distance formula, we're going to have the square root of x2, 9, minus x1, 5, squared, plus the difference of y2, 2, minus negative 3, squared. So, the distance between these 2 points is 4 squared plus 5 squared, or 16 plus 25. So, in conclusion, our distance between these 2 points is the square root of 41. Now, to give this a more realistic idea, let's look at the same problem, but look at it visually. Here we have our points 5, negative 3, 1, 2, 3, 4, 5. There's point A, and then we have the point 9, 2, 6, 7, 8, 9, and going up 2. I'm going to draw a line between these two, and I'm going to draw a triangle that represents the sides of our figure. Our vertical distance, as you can see, is 5, and our horizontal distance is 4. And so that's why we have the difference of our 2 points giving the hypotenuse as the square root of 41. As you can see, the graph goes slightly off of the graph that we have in our grids. This is why the distance formula is very effective versus a geometrical method or visualization. Let's look at number 2. On number 2, I want you to consider and think about the idea that we're really talking about the change in x squared and the change in y squared. If you remember on our triangle from the previous problem, both of our values were positive because we're thinking distance. So let's look at this problem, and I want you to think with you is as I circle my x's from 6 to 10, how far is that? Well, that's 4 apart. Then, from 7 to 11, how far is that? Well, that also is 4 apart. So as you think about visualizing this as a triangle, you'd have a triangle that was 4 by 4. And so my answer is the square root of 32. Now in this case, we're not allowed to leave our answer in this manner because it's not simplified. So let's break it down as 16 and 2. That gives us the answer of 4 root 2. So in some cases it's easier to think about the distance formula using the idea of change. Let's look at number 3 and think about it using the change idea. The distance equals the change in x squared plus the change in y squared. Well, I'm going to circle my numbers. Between negative 4 and positive 4, that's a change of 8. Between positive 2 and negative 3, that's a change of 5. So I have the square root of 64 plus 25, and my answer is the square root of 89. So it all depends on how you want to consider and look at our problems, whether it's difference or change, but both are correct.